Good morning, my YouTube viewers. It is Crystal here. I'm just here because I wanted to give you another code review. And basically, what I wanted to do is give you the code review on Kaggle community competition on water quality. And basically, what happened is I was writing a blog post and I wanted to go ahead and do some machine learning to go along with the blog post, and that's why I did this community competition. So when I initially did the community competition, there were only 2 teams, so me and one other person, and so I scored number 1. I scored better than that other person. But since I did the community competition yesterday, now there's 4 teams, and I guess they sort of like improved upon their work. And so and now I'm last in the leaderboard, but I was initially first in the leaderboard. But I like to think that people looked at my code and got some tips from my code and then improved their code because of the tips that they got on my code. And the reason why that is because I always make my code public. And you can see here that I have 37 views on my code. So I had a public score of 0.07619, which I don't think is too bad. So here's the problem statement of the water quality competition question. It was a community competition. A growing number of factors, including pollution, population expansion, and climate change, are putting the world's water resources in danger. How to obtain enough water to satisfy human demands while also conserving the integrity of aquatic ecosystems is a recurring concern as the world's population rises. The Pacific Institute works on global water resource issues in partnership with stakeholders to make sure that people and nature have access to the water they require to survive today and in the future. In this competition, your aim is to train a machine learning model based on the water quality data provided to you in the training file and further predict the quality estimation result for the test dataset. So this is a very interesting data set to use because it was a European agency provided that data set. So it's real world data that has been provided for this. And a long time ago, I was watching television, which I don't have a TV anymore, but I was watching television a long time ago. And they said in the future, the wars are going to be fought over water. So that's very interesting as well. So let's see what my program has to say about predictions. So the first thing we're going to do is we're going to import our libraries. We're going to import NumPy as NP, which is for numerical computations. We're going to import pandas as PD, which is for data processing. We're going to import matplotlib.pyplot as PLT, which is for graphical visualization. We're going to import Seaborn as SNS, which is for also visualization but statistics. And we're going to import OS, which is the operating system. We're also going to import sklearn when we select our model, and sklearn is Python's machine learning library. We're going to load the files. So when we load the files, we're going to use a for loop to load the files, and we're going to get all of the files that are used in this program. And we found train test and sample submission. Then we're going to use pandas to read the files. And so we're going to take those files, we're going to read them in, and we're going to convert them to data frames. And the 3 data frames we're going to create are going to be train, test, and submission. So you see you've got train here. It's got 28 columns of data. And the last column is going to be result. You've got tests, which has got 27 columns of data. And then you've got submission, and that's what Kaggle wants to see when you submit your results. We're going to analyze the result. So you can see the result here. You can see that most of it is close to 0. It's between 0 and 1. So that's your result. So it looks to me almost like it's like a probability, really, if the result is between 0 and 1. So that's very interesting. Results between 0 and 1. So that's something else that's very interesting. We do with value counts, and you see you've got a lot of rows where the result occurred only one time. And then what happens in that regard is the model cannot really make predictions on something that has occurred only once. Oh, excuse me, it's early in the morning. And the model has occurred only once, and so really I just made the decision to remove all of those items where the target has occurred only once. So I dropped the rows where the value appears only once. So is multi equals train, and then brackets result dot value counts is greater than 1. So if it's greater than 1, it's going to go with is multi. Filtered equals train result dot is multi dot index. Train equals filtered train. So you can see that we reduced the number of rows to 3692. So there were a lot of instances where the target appeared only once, and so it wasn't going to do a very good job. It wasn't going to be able to make predictions on it if it appeared only once. So now we analyze the train again, and you can see we have a 0 to 1, but you can see that there are a lot less hits, really, if that's what you want to say it, because yeah, we have a lot less data to make predictions on. So we do a value count again, and you can see that we have removed everything that appeared in the results only once. Check for null values. You can see that you've got some null values in here, so we've got to impute those null values. So what I did was I dropped all the null values from the train set. So now there's no more null values, because there's several ways that you can deal with null values, and one way is to impute them and another way is to drop them. But I just decided that since it's train set, to go ahead and drop them. Now we're going to combine our train and test. So target, that equals train result. Combi equals train dot drop, brackets result, comma axis equals 1 dot append test. And then here's your combi. So we combined train and test. And now what we're doing is we're dropping the ID from combi because you don't need it. And the reason why you don't need it is because every row of data is indexed. Now we're going to analyze combi, so you can see here what type of column each column is, whether it's an object or a float. So we're going to check for null values. You see that we've got some more null values, but we cannot delete the null values. We cannot remove the null values from the test set. And the reason why is because when we submit our work to Kaggle, it has to be, you have to have all the values in there. So what we're going to do is I'm going to replace all the null values with 0. I initially tried to replace all the null values with the mean of the column, and it just caused the program to lock up. It just wouldn't work. And because of that, rather than replacing it with the mean, excuse me, it's really early in the morning. Rather than replacing it with the mean, I decided just to replace it with 0 because it just wouldn't work with the mean. I also could have used an imputer in sklearn, but I didn't want to. I didn't want to use sklearn really, because sklearn is a machine learning library, but it's got lots and lots of functions in it. But I just didn't want to use sklearn, and there's the possibility that I could have gotten a better score if I had used sklearn's iterative imputer or KNN imputer, but I didn't do that, and I could have. If I really was motivated, I could see if using sklearn's imputer would improve my score. So now what we're going to do is we're going to encode all of the columns that are objects. We're going to use sklearn's ordinal encoder to do that. So now you can see that the object columns are no longer strings, but are numbers. Now we're going to create a heat map. So core equals combi.core, sns.heatmap core, and so we've created a heat map, and you can see that some of the columns, not very many, but some of the columns have a high correlation. And so because we've got a lot of columns here, and this is the correlation between all the columns if you're interested, but because we've got a lot of columns here, we want to remove the columns that have a high correlation. So we've inserted code to remove all of the columns that have a correlation greater than 0.9. So now instead of 27 columns, we've only got 26 columns, which means we were able to remove one column. Now we're going to normalize our data, and then when we normalize our data, what we're doing is we're taking all of the values and we're going to convert them to a value between 0 and 1. And the reason why that is because it's easier for the model to make predictions if all of the data is close together on the same dimension. Define our x and our y variables. Your y is your dependent variable, so it's going to be your target. Your x is comb_b, 0 to the length of train, and your x test is comb_b, the length of train all the way to the end. So now we're going to set up our training and validation sets using x, and when you do that, we have to take the target, and you have to attach it to x. So x target equals target. So we've already done that. So then we set up our train. Train equals x dot sample, brackets frac equals 0.9, comma random state equals 42, brackets val equals x dot drop train dot index, x train equals train dot ilog, square brackets, colon, comma, colon, -1, square brackets, y train equals train dot ilog, square brackets, colon, comma, -1, square brackets. And then val is done exactly the same way as train was done. And now we check our shape. So you can see the shape of your different data frames or your different variables. And so the shape looks good. It's what we want it to be. Now we select our model, and in this instance I decided to select gradient boosting regressor, and I had an accuracy of 93%, which I don't think is too bad. And if I had wanted to improve my score, I could have used Grid Search CV to try to find the best parameters, but I didn't do that, although I could have done it to maybe improve my score a bit. So we predict on the validation set, and we had a score of 92.7%. Check our metrics. We had RMSE, which is your root mean squared error, of 0.04%, so that's not too bad. We compare our actual data set to our predicted values, so it doesn't look that bad. And now we're going to visualize. We're going to visualize the data, and it doesn't look too bad because the model that I used before, gradient boosting regressor, was linear regression, and linear regression didn't look anything like this. And so you can experiment with the models to see if you can get a better visualization. And then if you get a better visualization, then there's a possibility that you'll get a higher accuracy or a lower error as well. But this gradient boosting regressor looks a lot better than the original model that I used, being linear regression. So you can experiment with the models to see if you can get a better model. You can also experiment with the imputer to see if using a different imputer will improve your score. There's always things you can do. We're going to predict on our text set. Prediction equals model.predict x test. So we see our predictions here. So now we're going to prepare our submission. Submission brackets result equals prediction. Submission dot to CSV. Submission CSV index equals false. Submission equals pd dot read CSV. Submission dot CSV. Submission. So this is our submission. This is what we submitted to Kaggle. And when we submitted it to Kaggle, I got a 0.7619. So we'll just look at the competition question. Look at the leaderboard. Okay, so now yesterday when I did this, I was number 1 on the leaderboard. But since that time, 2 more people have jumped in to form teams. And so they did a lot of work to try to improve their score, and so I'm no longer number 1 on the leaderboard. I'm number 4 on the leaderboard. But see, they keep working on it. Obviously, they've got a lot more time than I do, so they keep working on it to try to improve their score, but I don't have the time. I'm just happy to get on the leaderboard. But I was very happy that I was number 1 for a very short period of time. You can see. So the first one I did was 0.15573, and the second one that I did was 0.07619. And since this is a regression and you're looking at the error, you want to get your error as low as possible, and I thought I had a pretty good error. So that's it. That's it for this particular code review. And what I will do is I will leave a link to my the code, the Jupyter Notebook, in the description box of this code review, so you can look at it if you want to, and who knows, maybe you might want to join the competition as well. So I would like to thank all of my subscribers for supporting my channel. Thank you very much for watching my video. If you like my video, please like, subscribe, and share. And I look forward to making more videos, code reviews for you in the future.